So we want to talk about functions. And today's topic primarily is going to be over function evaluation, evaluating algebraic expressions, analytic expressions inside functions. Before we get to that, let's give a formal definition of a function, or at least as close to a formal definition as we can, a good pre-calc definition. So a function is a relationship between two variables such that the, let's say, for every value of the independent variable, which we usually call x, sometimes t is a very common independent variable, there exists, or there corresponds, let's say, exactly one value of the dependent variable. Why? So functions, you kind of want to think about, in the real world sense, functions are like things we measure. In some sense, it's like we usually have some sort of independent variable, some sort of data that we want to study, and we want to measure things from the data. Well, what are we measuring? Let's say my data is, runners around a track. What do we might want to know? Well, maybe I want to measure the top speed of everyone. That might be one function, and we can measure function of someone's top speed as, say, time they're running around the track. We could also measure, I don't know, acceleration. We can measure total distance traveled. Other ways you can kind of think about functions. So let's write just down some concepts, I guess we could call them. Functions are things we measure. Other ways you can kind of think about it as functions generalize are basic math operations. And actually, let's say specifically basic arithmetic. So plus, minus, multiply, divide. So examples are, we usually give functions in 3 different ways that you'll see them in this course. Analytic functions. A function defined analytically, I can write as something like f of x is equal to 3x minus 4. And sometimes we'll put a y equals 3x minus 4, or we'll call it a specific function. And we read this as f of x, so the function of x, that x is our independent variable, and the relationship to get the y variable is given by this expression, which you can kind of see as a generalization of these basic math operations. We've got multiplication, subtraction in here. This function says for every number, for every input number, multiply that number by 3, then subtract 4. So instead of just a given add two numbers, subtract two numbers, we can apply sort of a sequence of arithmetic operations to generate functions. Of course, other examples, we might have things like g of x is equal to x squared minus 2x plus 2. This says take a number, square it, subtract off 2 times the number, then add 2. We also like to give functions by tables. So sometimes you'll see x, and let's have h of x. This only describes a function where our domain, the only thing we know about this function, the set of input variables, is there's only 4 numbers for our independent variable, 4 values that our independent variable can take. Likewise, we can also give graphical information about our functions. So let's say I draw a function that does something like this. And let's call this, say, j of x. So hopefully none of this is too foreign to you guys, and you've seen all sorts of different examples like these. So let me, I kind of want to keep our functions handy. So the next thing we want to do is evaluate functions. So evaluating a function simply says, well, if I choose a specific value or a specific expression for the independent variable, what happens to the dependent variable? Or how does the expression change for the dependent variable? Let's start with the second 2 examples, because with analytic is really what we're going to focus on in our in-class activity. And in general, in calculus and in Calc 2, of course, being able to manipulate these analytic expressions is kind of a big limiting point. So for a lot of students, especially starting off in pre-calc, this is kind of a big skill and a big area where we see students starting to lose points. So we definitely want to practice working with that. Our tables and graphs hopefully are fairly straightforward. So for example, if I want to say h of 1, this simply says that x is 1, and what is h going to be? Minus 3. Or of course, we could call this the y variable. Likewise, h of 3 gives me 4. And if we say something that's not given, if I say, what is h of 6? We often write DNE, stands for does not exist. Since we are not given any information about what happens if the x variable is 6. Do the same thing on a graph. So in this guy, we could say, what's j of 0? Graphically, so remember that our independent variable is on the horizontal axis. Our dependent variable y is on the vertical axis. So when we say 0 on the x, we're right here at 0. And I should label my x-axis here. 1, 2, 3. We'll just say 1, 2. So step up by 1 for each tick mark on both axes. And j of 0 is just going to be 2. J of 2, I go to 2 on the x-axis up, and my y value corresponding to that is 3. And likewise, let's see, what other points did I include? 1, 2, 3, 4, 5. So j of 5 gives us a negative y value of -1. Of course, we can plug in numbers to the analytic expressions again. So let me just go ahead and rewrite those. So our f of x was 3x minus 4, and g of x is x squared minus 2x plus 2. So evaluating these guys numerically, we just have to perform the sequence of operations defined by the function, or that the functions define. So f of 0 means we just plug in a 0 wherever we see of x. So this will be 3 times 0 minus 4, which will give me a -4. F of, let's pick a different number, let's say something like 11. Means we just plug in 11 and now perform our given operations. So we'll have 33 minus 4, and so we get 29. Likewise for g of x. A little bit more operations to do. Let's say g of 1. We will have a 1 squared minus 2 times 1 plus a 2. If it helps, I always encourage everyone to put parentheses around any of the x's when you're plugging in numbers, and especially when you're plugging in more complicated expressions, because especially with squaring things, you can easily get mistakes if you don't do it correctly. So 1 squared is 1 minus 2 plus 2 simply gives me 1. And let's do one more here, and let's actually say g of minus 1. Particularly, these negative numbers are where it's going to be important to make sure that we do have the minus 1 in a parentheses, because we are squaring that entire minus 1. Minus 2 times minus 1 plus 2. And what do we get now? So minus 1 squared gives me a positive 1. Plus 2, and here we'll get 5. So nothing too fancy. But as we'll see with every class of function that we learn in this class, we often want to plug in algebraic expressions into a function. So for example, let's keep the same functions, f and g. But if I want to say, what is f of x minus 2? As we'll see, this x minus 2 in the function, well, we can graph the function f of x. And now saying, well, graph the function f composed with x minus 2 is going to shift the graph to the right. But we might want to come up with a nicer analytic expression for that, simplified. So what we want to do is still, in parentheses, wherever we see an x, or wherever we used to see an x, we're now putting an x minus 2. So we simply put x minus 2 to replace that. And we can simplify. So this will be 3x minus 6 minus 4, 3x minus 10. Likewise, we can do things like f of, let's say, minus 2x. this corresponds to a horizontal compression by a factor of 2, as well as flipping it horizontally is what this negative is going to do graphically. The analytic expression in for the x, now we're just putting a negative 2x. And then multiply, subtract 4, and to simplify it as we can get. Any questions on this? So let's do one hard one, because I do want to get started on the in-class activity. Well, we'll see this often, and you will see this a lot in calculus. Now instead of x plus 2 or x minus 2, I'm kind of introducing a dummy variable or a dummy constant, x plus h. We're shifting the graph a little bit, but by some arbitrary amount h, and we don't know which direction or how big that is. But you want to practice simplifying these. So remember, our g of x, a bit more complicated. We've got squareds in here. And wherever we see an x, we're simply going to put an x plus h. So that x plus h has to go in parentheses, squared. Then we have a minus 2x. So that'll be a minus 2 now times x plus h in parentheses. And then the last term was just plus 2. You have to mind the parentheses with all of these, because now we're going to distribute, we're going to FOIL this guy out, and then we're going to simplify. So FOIL this guy out, practice doing it, or maybe if you've kind of learned the trick, should be the first term squared plus the second term squared plus 2 times the cross term. We're going to distribute this minus 2, so it'll give me a minus 2x, minus 2h. And then the plus 2, nothing else is going on with that. And then now in the IC, you'll have to do harder things. Sometimes we want to add and subtract functions themselves. And simplify expressions like this. And even sometimes we take that and then divide by an h in which to simplify a little bit more harder expressions. So this guy here is called the difference quotient. We'll see this come up hopefully a few times in class, and you will certainly see it come up at the beginning of calculus in evaluating this. So for now, let's just kind of practice doing these function evaluations. Any questions on any of that?